Hello, everybody, and welcome to another recorded Zoom conversation, this time with USGS geologist Lydia Staisch down in Portland, Oregon. Lydia, it's winter time. What was the commute like for you this morning?
Well, usually it's a comfortable bus commute or bike commute, but today I
Hmm.
took the bus and it was a bit delayed. So thanks for your patience again. Um,
Sure.
but yeah, we got here.
A little bit of sleet, it sounds like.
Little sleety, yeah.
Okay. All right. Well, you made it. Thank you. And I appreciate your time this morning here on a Wednesday morning in early February. Thank you for watching the conversation that I did a couple of days ago with Sky Cooley. You know that I'm in this zone now about thinking about, I don't know if it's a crazy question or not, Lydia, but I'm just literally asking, did the flood basalts in eastern Washington and eastern Oregon cross the Cascades at some point?
Mhm.
Is that a crazy question? Have you been thinking about that at all with all of your work in the Northwest?
Yeah, it's definitely a question that's cropped up a few times. So I don't think it's a crazy question because people have been curious about it for a long time. And so especially when I started my postdoc 10 years ago at the US Geological Survey, I started thinking about this because I was working on the uplift history of the Yakama folds, which are just adjacent to the Cascade Range.
Mhm.
And so knowing where the basalts were and what mechanisms have uplifted them through time was definitely something that I was curious about and of course read a lot about what others had been saying about, where were the basalts and how much have they been uplifted and why and where and all that kind of stuff.
Well, let's start there then, because I think you maybe can help us more than most about how separate are these questions about the Yakima fold belt and that deformation and the Cascade uplift and that deformation. Is it apples and oranges, or is there an intersection of both of those conversations?
It is a curious question, and it's something that I've struggled with a long time. And the reason why I've struggled with it for a long time is because the Cascade Range, as well as the Hog Ranch anticline, which is just to the east, are both north-south oriented anticlinal antiformal structures. So the compression is east-west. But the Yakima folds, they're kind of this fanning type morphology, but they're roughly, on average, sort of east-west oriented and therefore north-south contraction. And so it's kind of a funny situation where you have two sets of structures that are active since the Miocene, since the basalts, because the basalts are deformed on
Right,
both sets of structures,
right.
in both an east-west fashion as well as a north-south fashion. And so and they have both been active fairly recently. We can tell from the geology, and from even seismic, paleoseismic evidence for deformation. And so I think they've been sort of trading off, uplift comes in one, and then the Yakima folds start going, and then the Hog Ranch anticline, and then maybe the Yakima folds keep going later. So it's there's two things happening at once. And for structural geologists, we don't like when there's compression in like every direction at the
Yeah,
same time. It's
right.
weird.
Yeah.
Yeah.
Yeah, right. So, in the classic sense, structural geology wise, you're squeezing this way and you've got extension going the other two in a map direction, and you're saying we
Yeah.
have basically compression from four different
Yeah.
directions simultaneously, roughly? Like,
Kind of. So
yeah.
in structural geology, we say sigma 3 is maximum, in this case, compression.
Hmm.
Sigma 1. Sigma 3 would be vertically oriented because that's where we're thickening the crust. And then sigma 2 is sort of the intermediary stress. And that in this case seems to be switching between sigma 3 or sigma 1 and sigma 2 keep on switching between north south east west, north south east west. And so the exact timing is very difficult to understand, and whether or not they can be sort of simultaneously, or the compressional stresses both north south and east west oriented are similar in timing and in magnitude. It's something that has definitely flummoxed folks for a long time, and a lot of smart people for a long time.
Sure. Okay, well, let's get so you've got a couple figures you might want to share. Is that out in the fold belt, or is that more Cascade proper?
It's in the Columbia River basalt, or in the Columbia River Gorge area.
Okay.
So I I have some of those figures to share, but there's also some conversation I think would help to discuss beforehand
Good.
that
Let's
sort
do
of
it.
leads up to that.
Good.
So I know that you and Sky talked a lot about when did the uplift history happen? What were the Cascades doing before the basalts, during the basalts, after the basalts? And in this case, I'm referring to the Columbia River flood basalts mainly.
Thank you.
And so the Cascade Range has been slowly rising, fairly continuously pulses in pulses of, low amounts of uplift and higher amounts of uplift, probably since its onset 40 to 50 million years ago. But one of the questions that I know you guys asked was, could that have been fairly subdued topography for a long period of that earlier history?
Mhm.
And I would say that there is some pretty good evidence that the topography was there, but it was subdued. And a lot of that comes from stable isotope measurements of various different materials in the forearc and in the back arc. And so this is helpful for understanding sort of what is the orographic precipitation, because if you have a large mountain range, you have dry climates relative in the back arc. Whereas if you have a, a low mountain range, then the seasonality is a little bit different and you get a little bit more of the precipitation to go that way. And
Hmm.
so dating uplift can be done through looking at stable isotope geochemistry of dated markers, different units that have the right chemistry to look at. And there's also been a lot of work on low temperature thermochronology. And this is sort of using crystals like apatite and zircon that retain products of alpha decay above a nominal closure temperature. As those rocks rise through the crust, that's measuring rock uplift, not topographic uplift, but rock uplift, which they are related.
Okay.
And so those are two methods that have been used for a long time. And both of them have been used in the Cascades to suggest that there was some topography probably before 15 million years ago, and there may have been
Hmm.
a pulse between 27 and 15 MA, but that those topographies remained relatively subdued probably until about 10 to 12 million years ago. But another really good way to look at uplift is if you have some sort of marker, some sort of geologic marker that's tied to a river elevation or something that's low elevation, something like the Columbia River, for example. So the Columbia River is a really spectacular location and a spectacular feature too, because it's one of the only rivers, or perhaps the only river, that crosses an active volcanic arc in the world. And so we have this massive river. It's been tracking along through the Cascade Range for at least 15 million years, probably longer.
Mhm.
And it's tied more or less to sea level. So it fluctuates a little bit with sea level rise and sea level fall over geologic time, but it's relatively well fixed. And then there are these tributaries that come in from the side, from the north and the south in this case, that are also tied to the base level of the Columbia River. And it's down those that we can find some really important geologic markers, a bunch of different basaltic units, both the Columbia River flood basalts, but also some more local ones to the Cascades that we know the timing of, and we can relate them to different their interactions with river level, because
Hmm.
it's pretty noticeable when something like a basalt enters the water. You get these very unusual features. And so that's a lot of the work that the Pacific Northwest Mapping Group has been focused on in the Columbia River Gorge, is dating different units and trying to figure out how they relate to the uplift history of the Cascades.
So far, I think I'm hearing that perhaps before 16 million years ago, when we have the flood basalts, you do have some hints. I don't know if it's your work or you've just been keeping up on people's work over the decades in the Cascades, but there is a little bit of relief using that isotope work. Um,
Yeah.
what markers were they using? If it's not your work, maybe you don't know, but what markers were they using and what kind of elevations do you think we're talking about at times prior to 16 million years ago in the Cascades?
So the different work has been done is on various different geologic units from as far back as Eocene time through the
Okay.
Miocene and through
Yeah.
Pliocene time. So different units. So the Ringgold Formation is one of them in central Washington. There's various different geologic units like the Deschutes Formation in Oregon or the John Day Formation in Oregon. And these have been used where basically they're looking at either fossil remains of animals or of plants or of carbonate material that's formed naturally in like soils or in lake facies that are they're precipitating carbonate, whether it's tooth growing or bone growing or lake carbonate, and they're sequestering their isotopic composition from their surrounding waters or plants, or basically tied to the meteoric water. And so
Hmm.
as that changes over time, global climate changes, of course, then we see shifts with global climate. But there's also local climatic effects that can be induced from
Hmm.
uplift of mountain ranges. And so
Hmm.
it's that a lot of that work, it's work that was done far before I started working in the Pacific
Right.
Northwest.
Right.
And the researchers have found that there's decent evidence that there may have been some amount of uplift between 27 and 15 MA, that there was a sort of a pause or a subdued uplift signal at the time of the Columbia River flood basalts. But then after the basalts were erupted and sort of finishing up what they were doing,
Right.
decimating our landscape more or less,
Yeah.
um,
Totally.
that there seemed to be a renewed pulse of uplift. And that's by carefully looking at the stable isotopic compositions of things over a long period of time and comparing it to global climate. And when it doesn't agree with what's going on in the global climate, figuring out, well, what could have been happening locally to induce those changes.
Couple more things right there. This is really interesting. I know you're heading somewhere, and we're eventually getting to a couple figures, but this is the part that of the story that fascinates me. So, calling back to our first 5 minutes of this conversation, you're kind of saying both uplifts are happening roughly simultaneously. The Yakama Fold Belt uplifting and the Cascades, or they're intersecting, and it's tough to parse out. It's not like we do all the Yakama Fold uplift and then we do a bunch of Cascade arching. It doesn't sound like that's the case. Um, so when you say there's renewed uplift right after the CRBs, let's say, are you talking both in the Cascades and the fold belt? Or are you talking mostly fold belt? Or just anytime you say uplift for our discussion today, you're kind of
Yeah.
talking both sets of ideas are doing an uplift simultaneously, roughly?
Yeah, I was mostly focusing on the Cascade range because that's,
Okay,
sort of what you were
that's the
interested
topic.
in.
Right,
Yeah,
right.
yeah. Both
Okay,
did happen at the same time, but I've been focusing more on the impact of the Cascades because they have sort of
good.
a broader regional effect on the climate.
One more thing, and then we'll move on. Have you thought much about the Yakima Fold trends going right into the Cascades?
Hmm. Yeah. Yeah, absolutely.
And as we just hike the PCT north from Cascade Locks up to Snoqualmie Pass, and we look at the structures, you and I,
Hmm.
are we, as we're going north, are we going over an anticline and a syncline and an anticline and a syncline as we go up the crest of the Cascades? And does that make sense with the Yakima folds off to the east?
Yeah, so how the structures interact between the Yakima folds that are coming from the east to the west, and as they approach the Cascades, they kind of start doing a couple different things.
Hmm.
In Washington, it seems like a lot of them start to coalesce and organize themselves towards this northwestern structure that has a little bit more strike slip possibly on it. It's probably still got some crustal thickening associated with it too, but they sort of merge in a way, like I'm talking more like around Menashtash Ridge. And
Okay.
so what those structures are doing exactly throughout time, it's really complicated to tell because, the geology is really rough in that area.
Right.
Um, but then closer to the Columbia River Gorge, some of those structures, they're actually trending a little bit more southwest trending, and they do seem to intersect the Cascades, and there seems to still be some uplift along them as well,
Hmm.
independent of what the Cascades are doing. And yeah, so there is sort of two two uplifts going on at the same time. Well, roughly the same time.
Well, you can probably guess where I'm going with that question. I'm hot on this idea lately of secret passageways through the Cascades for some of these Grand Ronde flows. And if we're projecting this Yakima Fold Belt anticline syncline roller coaster basically, and we just bring it right up into the Cascades, then maybe I'm backing off of the idea of we have a massive sheet of Grand Ronde crossing the Cascades, but maybe I do like two or three or four synclinal valleys essentially in the Cascade Arch. But I'm beyond now where I think we want to go. You're reinforcing a few ideas, but there's some new stuff here that I'm really interested in. Please continue. I'm guessing that you're heading towards a figure or two. Is that correct?
Yeah, yeah.
Okay,
So
let's go.
I'd love to here. I'll start sharing. So I'd love to share this a couple figures from some work that Jim O'Connor, my supervisor,
Ah,
led um, as part of a a field trip that we ran in the Columbia River Gorge. And this is
hmm.
one of the figures from a recent publication that we have, where I really want to focus on this figure down here. So
Thank
again,
you.
we're in the Columbia River Gorge, where the Columbia River is crossing the active arc. And we have a lot of the Columbia River flood basalts in the Columbia River Gorge. They flowed through the river network and they came into Western Washington and Western Oregon via that route for sure. Um, and so in this lower figure, we're going from west on the right side and east on the left side. And these different markers are basically different elevations in meters along the distance of the Columbia River, more or less, our mapping area. And the
Can I
different
interrupt?
markers,
I'm sorry,
yeah,
can I interrupt you for
absolutely.
just a second?
Yeah.
I think I've got this right. Are we looking south? Are we in Washington looking south to Oregon? So east
Yes,
is
I
on
believe,
east is on our left and west is on our right.
yep, that's
Uh,
correct. Yeah,
okay,
and there's
okay,
Mount Hood poking above
got it.
here. And
Okay,
so
thank you.
throughout the Columbia River Gorge, we see this arch of the Cascades.
Hmm.
In Hood River Valley, we start getting, uplift towards the middle of, or towards cresting up into higher and higher elevations of the Cascades. And then as you approach Portland, it starts going down and down and down and down. So there's
Mhm.
this arcuate feature of the Cascades in that area. Well, everywhere more or less, but here's an area where the river has cut through. And so we've got these really important stratigraphic markers. The ones in green that I'm showing here, this is a Miocene saddle mountains basalt, specifically the Pomona basalt that went all the way to the ocean, more or less.
Mhm.
And
Mhm.
so that's in green. And so we can see that we're uplifting, uplifting, uplifting since it was erupted about 11 to 12 million years ago. We don't have a lot of exposure over in this portion, but then you can sort of see that it's further to the west, it's further down. But another important feature I want to show are these reds and these yellow dots
Mhm.
here. And these are Pliocene lithocene tholiites, which is a kind of basalt, and the hyaloclastite, which is specifically when these Pliocene flows entered into the tributaries that go into the Columbia River and then entered into the Columbia River. The hyaloclastite is this where the basalt interacts with water, where it's at river level. And so
Hmm.
when we're tracking along these 3 to 4, well, more, yeah, 3-ish million year old hyaloclastites, we can see that they're also similarly uplifted on this arch as the Cascade. So again, I want to highlight their age. I wrote it down exactly to make sure I had it right.
Wow.
It's oh gosh, which side am I on? They are between 3.6 and 2.4 million years in age. And so the magnitude of uplift, if we compare the 12 million to 11 million year old Pomona member that's
Right?
been uplifted, and also the hyaloclastites, which are about 3 million years in age, we can see that the magnitude is not that dissimilar. There has been a bit more uplift on that Saddle Mountains basalt flow, but not a ton more, suggesting that a lot of this uplift, a lot of this arching that we see in the Columbia River Gorge portion of the Cascades happened since 3 million years.
Okay,
So that's a
hang on.
lot of uplift.
Hang on. Can you stop your share for just a second?
Yeah.
This is a big moment, Lydia. I need to see you now. This is big. I'm processing this in real time, but I think the what I'm hearing from that diagram, what I'm seeing from that diagram, this is almost radical, isn't it? That you've got 3 million-year-old lava flows coming through the Columbia Gorge, roughly, and they're horizontal. They're flowing.
So the
Uh,
3 million, yeah, so not almost. So they're erupting really close to the crest of the Cascades in Oregon mostly, and then they started going into Washington about 2 to 1 billion years ago. But they're erupting locally and they're coming down the tributaries that lead into the
oh,
Columbia River. But So they're not flowing down the Columbia River Gorge the same way that the Columbia River basalts did, but we can
Okay.
tie them to the Columbia River still. Even so, they're a little bit more local. They're not flowing down the whole river
Okay.
system, but
Okay.
they're still we can still relate them to the river level because the bases are hyaloclastic.
Got it.
Yeah.
The reason I think this is big, and I think it's still why you're saying it's big, is that you're a young uplift person. You're a three
Apparently.
you're not to label you, but you're a 3 million years or even slightly younger than 3 million years ago that we do
Yeah.
a lion's share of the uplift of the Cascades. Am I hearing that correctly?
Yeah. And so I have some values to share. So
Holy
the
God. Yeah.
the es
Good.
the estimates from the older basalts, 15.6 million year old basalts in the region suggest that there's been about 1.2 to 1.7 kilometers of uplift based on, comparing where they are up at close to the Cascades versus where they are in the Columbia Basin. And that's really similar to the estimates from um, post-Miocene
Right.
uplift of the Cascades from the stable isotopic measurements too. Okay, so
Hmm.
we can say since 15.6, that much uplift has happened. But what we're estimating from the Columbia River Gorge is that there was about 900 meters of that, which is between half to three-quarters of that post-Miocene uplift, at least there, was since 3MA. So
Since
it's in agreement. It's just saying that there's a lot more has happened a lot more recently. And that's based on looking at these basalts that are younger in age, that are tied to the river level, and seeing sort of where they stack up, how much uplift they've experienced too.
hmm. So in Sky's conversation, as we were wrapping up, Sky's like, "Hey, there's a big difference between 12 million years ago, which is some of the votes for the beginning of the Cascade Uplift, all the way up to starting the Cascade Uplift 4 million years ago." He says there's a lot of wiggle room between 12 and 4, but you're not even in that window. You're younger than 4 with a lion's share of the Cascade Uplift. Are you out on a limb with that? Have you published on that? Do you feel like this is, are you in the lunatic fringe now, being that young? Or are there a number of people who are seeing it that way now, at least unofficially?
So it is published in the GSA field trip guide that
Yeah.
Jim led. And
Okay.
so I don't think we're in the fringe. So, and that's because a lot of these estimates have had sort of maximums on them. They said like since 12, since 10, since
Right.
7, we see this much
Right.
uplift. But
Right.
this is a really unique opportunity where we have well-dated, basaltic units that are erupting locally and just happen to be so well tied to a river
Hmm.
that's also cross-cutting the arc.
Hmm.
But again, this is a central part of the Cascades. This is right on the border between Oregon and Washington. So the Washington Cascades further to the north, they could have experienced greater amounts of uplift earlier. We've got a long arc all the
Hmm.
way from BC, Canada down to Northern California.
Right.
And so
Right.
this, I don't think it's fringe because it's actually, I would say it's in agreement. It's just refining the ages. And we're not saying the whole Cascades did this, just at least this central part seems to experience a lion's share of the uplift, at least half since 3-ish MA.
Okay, I'm loving this. I want to take a detour from the Cascades for a second. If we start thinking about the Yakama River Canyon or the Grand Ronde River Canyon or many of these canyons in the Pacific Northwest, inland of the Cascades, which I know that you know well and you've been thinking about a lot, are you saying that incision with many of those river canyons is also very energized and youthful, younger than 3? Does it all work together?
So some of it does seem to work together. And the Yakama Canyon is the one that I know best because I did my postdoc on the Yakama Folds there. And the Yakama is kind of like the Columbia River in that it's cutting through the Yakama Folds really nicely. And so the the ages are unnervingly similar. So we've got this. It's honestly it's quite bothersome to me. I feel uncomfortable saying this, but so we have the Thorpe gravel in the Kittitas Valley, and we also see time equivalent, fluvial gravels in the Sela Valley too. And they're at a little bit different elevations, but fairly similar, showing that there hasn't been that much relative uplift between those two valleys. But the
Mm.
middle part, where the Yakama River cuts through Menashash Ridge, Sheila Butte, Umtanum Ridge, those ones, the Thorpe gravels are actually uplifted there, and the stream profile inversion sort of stuff that I did for my postdoc is also showing that quite a lot of that uplift happened since about 2.5 million years ago. There's probably a
Huh.
bit before, but also a lot of fairly youthful uplift.
Fairly youthful. And that's where we finished with Sky. I read that little passage from J. Hoover Mackin, writing it in 1946, and he was describing kind of this inset. Oh, it's almost like the Grand Canyon. There's an inset inner gorge that's kind of really aggressive, youthful, and then there's the kind of broader, more subdued. And I see that between Ellensburg and Yakima all the time. It sure seems to me like it's almost like this peneplain thing, and then there's this incision thing. And Sky finished with saying, I think that inner thing is Pleistocene, which I guess is agreeing with what you're saying right now. That
Yeah, Pleistocene.
yeah, okay. Um, well, that was thrilling, and I don't know what to do. Like I've got a few letters in this alphabet series I'm doing, and I was going to use about 7 million years for the beginning of the Cascade Uplift, kind of splitting the difference between 12 and 4, and now I don't know, maybe I need to go younger than that to really do. I hear what you're saying though. That's in the Columbia Gorge, and I guess maybe that's where we'll finish in the last few minutes here, Lydia. I'm thinking of the South Cascades of Washington. I'm thinking about the Cascades between Snoqualmie Pass and the Gorge, and I think that's the most likely place where, if there is flood basalt crossing the axis of the Cascades, it's through there in a few places. I have had a bunch of viewers since the Sky conversation look up, and sure enough, it is Grand Ronde Flow up at Steamboat Mountain, and so
Yep.
there's a few of these little islands. You probably know about that as well.
Yeah.
Um, what? Well, no, hang on. You've got another figure. Did you want to share something else?
Yeah.
Okay.
I
Sorry,
think
I was I
it
was
sort
going a
of
different
relates.
direction.
Let
Yeah,
me see. Okay,
good.
I got to get back to Zoom. Where are we?
Hmm.
It sort of relates, I think, to that discussion a little bit. It's still focused sort of in the Columbia River Gorge area. Let's
Good.
see. Can you see my screen all right here?
Yes.
Okay, so these are three different panels we have. Same publication, the O'Connor et al. 2021, looking at three different basalt units going through the Columbia River Gorge. So here we have the Columbia River. You can sort of see that blue background going from Wallula Gap over here all the way towards Willamette Valley over here. We've got the
Hmm.
Klickitat River coming from the north, the Deschutes coming from the south. And so this blue polygon here, this kind of teal polygon,
Yeah.
is one of the Wanapum basalt flows, the Priest Rapids Rosalia flow specifically. It's about 15.9 MA. And
Mhm.
so I think it kind of relates to showing where there was low topography at the time it was erupted. So 16-ish million years ago, we've got the mapped extent is in these darker, sort of more solid blue polygons. And then our expected extent where we think it got to um, is is in the sort of more opaque or transparent blue. And
Hmm.
so that would suggest that, there's some low topography allowing for it to erupt to its extent into the Willamette River Valley over here, 15.9 MA. But so there's this uplifted region or potentially uplifted region at that time over here, suggesting that there could have been at least some topography. And, these individual flows, cumulatively, they're extremely thick, but individually, they're not always that thick.
Right.
And so, at least at this time, there seems to have been some topographic barrier to some degree over here in this southern Washington part of the Cascades. Now, if we go to the middle panel here, we have the Pomona flow. This is one of our important ones. It was the green dots that I showed on that
Hmm.
figure earlier. And there's a
Hmm.
ton of it all over the place in the Deschutes River Valley, or in the upper part of the gorge, rather. But the main river system seems to have, its way through, more or less, was the Columbia River north of where it currently is. Columbia River is down here right now, but it seems like there was an ancestral river further to the north. So this is about 11 to 12 million years ago, and then
Mm.
cutting through something similar to the gorge. And so again, it seems like there's something here that could have been at least locally a topographic barrier over here, and that there's a relatively narrow portion where we see mapped extents of the Saddle Mountains Pomona flow.
Hmm.
And then here, this bottom part is showing a couple different routes. The post Pomona is in this sort of orangish color. And then the Columbia River in the middle of the Cascades here starts swishing around just a little bit between these two different time periods. And so those low potassium tholeiites that are younger than 3.5 million years are shown here. And so it's a very narrow channel where they're coming down. But here we don't have a big basalt flowing everywhere to tell us, what was this topography doing? But at
Right.
least in these two time phases up here, 15.9 and 12-ish MA, it seems that there was at least something locally here that prohibited the basalts to flow over the what is now the Cascades there.
Yes, thank you. You know what so I think you know what, I'm going to draw something quick here, if you don't mind, before we quit.
No, you're good.
Um, I think I want to see a very similar map to what you just drew, but I want to see it for Grand Ronde time, or maybe specifically R2 or whatever the youngest of the batch is. Is that how that goes? N1, R1, N2, R2? I think that's right. So what is that right? Um,
I think I got the N's and the
yeah.
R's mixed, but
Oh, do
yeah,
I? Okay.
I, I
So
think yeah,
so
and two's last.
so if we have I like those maps, but it's almost like when I was talking to Sky the other day, I'm like, yeah, I know we got the intercanyon flows and we got the Saddle Mountains and we got the Wanapums and they're following these river courses. I'm aware of that, but how about the Grand Ronde time where we have so much more volume? And so uh, maybe I'm going to draw something similar to what I drew last time, but like, what if we had a similar looking map, but it's not at the Columbia Gorge, but it's Yakama and today's White Pass, and then basically a U.S. Highway 2
Mhm.
crossing, um, and 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 then we uplift it so we get the topography that you're talking about a little bit younger to shut the Pomona and some of those other guys and keep them down to the south. It seems to me this is there an older, slightly larger version of this CRB business crossing the crossing the Cascades just a little bit further north, or more to the point, if you and others know about Steamboat Mountain, has anybody tried to
Cross it over.
connect the dots? Right. Oh, I don't have a
Yeah.
good sense yet about where Steamboat Mountain is and how far north of your maps is Steamboat Mountain, but it's older if it's Grand Ronde.
Yeah, it's a bit older. And there is so I think the CH that you had on your map there was that Chehalis Basin.
Yes, yes.
Okay, so there is actually Columbia River flood basalt in the Chehalis Basin, but we're pretty sure we think that it came through the Columbia River Gorge again, and
See,
then there was
okay.
so voluminous. It was so voluminous though that it just spilled out further to the north. But in the Puget Sound, the like Blakely Harbor Formation, the other Miocene strata there is basalt in it, but it seems to be mostly from or all from the Crescent Formation, and they're cobbles that were eroding from the Olympics as they were uplifted. And so,
There is basalt in the Blakely Harbor Formation.
well, basaltic gravels.
Yeah, yeah.
Yeah.
And everybody assumes it's Silesia, but maybe it's not.
I guess we need to do some more chemistry on those clasts. But yeah, from what I've read, most people are of the opinion that it comes from the Crescent Formation.
Well, that's the last thing I want to do. And I want to draw again. This is what I was going to do before we remembered to get the other figure. If you wouldn't mind sticking around, I just, for the viewers, this is part of this discussion, and it's going to tie nicely, I think, with what we're doing with Lydia here today. So here's Oregon Cascades and Washington Cascades, and cartoonishly, there is flood basalt here Chehalis and like almost Grays Harbor and all that kind of stuff. And then, of course, the Oregon coast has a bunch of flood basalt as well. And Lydia's is helping us see that we've got all of these CRBs coming through at different times, different courses. The Columbia's got different pathways, even the Ginkgo flow cutting across and heading to Newport and everything else. But I've always been curious, are these flood basalts in southwestern Washington? Are we sure those are flows that came up, basically flowed north, as opposed to, are any of these possibly coming cross country? And I don't know, do you think anybody's really looked at those flows carefully recently, or that's pretty
Yeah.
open and shut case?
So it's a pretty good question. So there's two flows that really made it to Chehalis Basin the most, and one is one of the upper Grand Ronde flows. I think it's the Sentinel Bluffs formation or
Okay.
member.
Yeah.
And so that one would have been during that very eruptive time of the
Right.
Columbia River basalts. But the other one is the Pomona flow. It's from the Saddle Mountains, and that one is one of the ones where I showed that it was pretty channelized into the Columbia River Gorge. And so that one, I would say,
That
is pretty good chance that that one flowed through the gorge and
through the
spread
gorge.
upwards. And so I
Yeah.
think Occam's razor says, if that path was, simplest explanation makes the most sense, that if the Columbia River basalt group at Pomona time did that, then that would also explain why it did that in the Grand Ronde time too. But I will never say everything's possible. I would say anyone who's interested for looking for other routes should absolutely check it out because I wouldn't say it's a totally closed book. There's always room for more research.
And I like that open-ended ending to this because yes, I mean, obviously I'm like hungry for a narrative and I love this idea, but I need to back off when it's clear. But I'm sorry, I'm going to do it one more time just before we say goodbye. If we know we got the youngest of the, I think we're talking about the youngest of the Grand Ronde lava flows. I'll color them purple. If we've got the youngest of the Grand Ronde lava flows in the Rim Rock area, and we have the youngest of the Grand Ronde lava flows on Table Mountain and Mission Ridge, where they're doing skiing above Wenatchee. And even up here, we've got the youngest of the Grand Ronde flows, I think, like and elevate, like what are the elevations of each of these things? At Table Mountain, we're over 6,000 feet elevation. And then again, what's the northernmost part that we have these same youngest of the Grand Ronde flows over here? Are we then really saying that this is Occam's razor that we want to get everybody
That's a good
down? I
point.
mean, I don't know. Like it's that kind of thing that it feels like it's worth spending a couple letters investigating this because it's just fun. It's just fun to try
It is fun to
to
think about.
yeah, yeah,
Yeah,
totally.
I agree.
Okay.
Keep
Well,
talking about it, please.
thank you. Thank you. Well, Lydia, thank you for your time this morning. I really appreciate it. And just going to keep, I don't know who I'm going to talk to next, but I think I'll probably just who should I talk to next? If I want to keep going with this, who else has
Oh
been
gosh.
thinking about any of this? Has anybody been thinking about it? Again, it feels like 50 years ago, this was a narrative and
Mhm.
it feels like it's just gone the way of the dodo bird.
Well, let me think about people you haven't already talked about first, and then I'll try and come up with a list. But yeah, off
Okay.
the top of my head, I can't think of anyone right now. But
Okay.
yeah.
Good. Very good.
All right.
Okay. Well, thank you so much for your time, and we'll see you down the road, Lydia. Thank you. You know what?
Thank you.
Hang on the line for just a second. Let me just stop the recording, and we can just say goodbye properly here.
Okay.
Thank you.